Hey all, Chaos Bug off to you. And today we're talking about Sigma the some how to solve Sigma notation problems. Um so what is this? Now this is the Greek letter in the alphabet. I don't remember what number it is, but it's a letter in the alphabet called Sigma. Now a lot of you probably know it from memes, but what is Sigma used for? Now Sigma is primarily used in calculus, the study of, well, actually, kind of, well, yes, it is the study of. Okay, well, that's actually what is it now. Now, what is this video kind of? The issue is I don't know what calculus it's in. I don't know if it's AP. I don't know if it's pre-calc. I don't know if it's calculus. I don't know if it's college algebra. Khan Academy says it's college algebra, but it just seems too simple to be college algebra, especially lesson 2 of college algebra. But without further ado, let's try to solve this problem. So now, let's just get a problem. So let's do n equals 1, okay, and let's do 4. I'm sorry, I'm getting used to my drawing tablet, but it's kind of tiny drawing tablet. Okay, my drawing tablet decided to be a little weird today, so. So, 4. Okay, now how do you make sense of this? Now this is actually really simple. So now, because we only have 2 terms in this equation, it would be very simple. We just do 1. Okay, give me 1 quick second. Alright, so what we do is since we would go, since n starts at 1, we would go, it'd be 1 plus 2, because we're going next, we're upping n to 1 more, so we're initiating it to 3, initiating 4. I like to think in a Java and how integer and how arrays work, where you can change your array by doing in Java. I like to think of it kind of like Java, the programming language, where you can init your integer by 1. So like I start my integer at 1 in this case, just like how we would do it in math. And I would and I int my integer for every single one. So my integer becomes 2, 3, 4, and this would equal 10 in this case. This is just another way of writing a series. Now, let's make a little bit more complicated one to spice things up. So, let's do this, but have it like 2n plus 1. Now, this looks a lot more complicated. No, it's not. So now, what do we do? It's actually just as easy. So we plug in n once. We plug in n, so that'd be 2 times 1 plus 1 plus 2 times 2 plus 1. Then 3. And finally, 4 plus 1 here. So we got, I'm gonna put it in my calculator just because I don't feel like, let's try solving it. So that'd be 3. That'd be 5. That would be 7. Oh, go up to 2. That'd be 9. And so 3 plus 5 plus 7 plus 9 would be, let me think about it. 1 second, I'm just thinking in my head, would be 24. And that's pretty much it we have for this. Now, but I decided to actually throw in a little, I'm going to be tossing in another thing very similar to this. Now, we all know pi. Now, how does this relate to, sigma notation, whatever? It does actually have a lot of things to deal with it. Well, we know pi. We know, like, pi. I can't draw pi. We all know pi. This is a really badly drawn pi. But what we know as 3.14 is in fact actually lowercase pi. In the Greek alphabet, there's a lowercase and a lowercase, like we have A and B. And what is this? Now, this is just like sigma notation. I'm gonna be a really bad sigma again. I don't even care at this point. It looks nothing like a sigma. But what is this? Now, what's the difference? Now, it is quite literally just sigma notation, but instead of adding the terms, we multiply the terms. So, in this case, we do 1 times 2 times 4. And now, kind of like this, in this case, it would actually be the same as like writing 1 factorial. Actually, I might actually be writing factorials wrong. I forgot. I always forget if you write it here or here. I don't remember. But it's now, obviously, it's not going to be the same if we add things like n plus 1 or something. But in this case, if it's just like this, it's kind of like writing a factorial. So I tossed in pi because I wanted to. Hope you can figure out. Hopefully this helps in whatever you're doing in mathematics. Hopefully maybe your brain can now understand calculus or something a little bit more. However, I'm also kind of stupid, so probably not. And now let's do a little segment. Let's apply our skills at Khan Academy. I'm going to start doing it in some of these videos. So we're going to be taking these segment notation notes and seeing how well we can apply it. So, okay, now we're going to consider some. So, like we learned earlier, it's like this. We got 1 term, 2 term, 3 term, 4 term. And now, do any of these answer the question? Now we gotta check all they apply. So 3. So n. That'd be -3. Yep. 11. So 2 minus 16. 5 minus 16 minus 5 would be 11. So D. And I'm gonna guess this is correct. And now what about this? Does this make sense? So, the 6 minus 3. The 0. Okay. Now what about 2? So 12. Yep, because, alright, next question. Oh, this is a complicated, this looks like a little more harder one, so let's try to think about it. So we have 4 terms. So 1 term, 2 terms, 3 terms, 4 terms. I think we can cross out this term. I think we can cross out this one. I think we can cross out this one. What did I think about? Yeah, because I can cross it off because we have 4 up there. So it's pretty easy to deduce it. And we just see. So we deduced. And let's think of this one. So we start at 2. We have 4. So 3 times 1 minus 1 would be 2. Alright. 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 Okay, this one is definitely correct. Now, let's think about this one. Okay, so we start at 0 this time, and 2 plus 0 would be 3. 5. Alright. 8. I think this one's correct too. Alright. And the final question, can we get it all right? Or we gonna fail? At least we got a third out if you get this one wrong. So let's think about this one again. Oh, this is a little bit more tricky one. Okay, 4 domes. I'm not gonna get too cocky and just guess one, so we plug in M. So 6, that'd be 8K minus 6. Oh, this one. Yep. And we got a 4 out of 4. Good job. Well, see you in the next one, guys. Like, subscribe, guys, please, or else I will be really mad. And goodbye.